section 4.7. Our objective today is I can apply definitions and theorems for altitudes, medians, and perpendicular bisectors. So first of all, we're going to start out with the definitions. So the median of a triangle is defined as a segment from a vertex to the midpoint of the opposite side. Okay, so for example, so if this is triangle ABC, then from vertex A, the median would be a segment from A to segment BC, where M is the midpoint of BC. So therefore, I would know that BM equals MC by definition of midpoint. Or, this is supposed to be the same triangle, A, B, C. From vertex C, then X would be the midpoint of AB, and segment CX would be the median from C to AB. And so therefore, AX would be congruent to BX. And I could have a median from B. So the median from B to segment AC would intersect AC at point Y, which would be a midpoint, and therefore I would know that AY is congruent to CY. Okay, so if you have a median, then you know you have a midpoint and therefore some congruent segments. Okay. Then the next definition is the altitude of a triangle. Okay, and by the way, going back to median, it doesn't matter what kind of triangle you have, whether it's acute, obtuse, or right, all medians are inside the triangle. Okay, so, and that's going to be important later. So if you have acute, obtuse, or right, doesn't matter what kind, the median is inside. And you'll see in a minute why that makes a difference, because for the altitude, it's not always inside. Okay? So first of all, the definition of the altitude of a triangle is the perpendicular segment from a vertex to a line that contains the opposite side. Okay, and the key here is a line that contains the opposite side, and you'll see why in a minute. Okay, so if my triangle is acute, okay, this is A, B, C, then it would be the segment, let's say I'm going from A to BC. It would be that segment, okay? Or if I'm going from B, if it's acute, it would be this segment. And if I'm going from C, again, if it's acute, it would be that segment. And notice that they are all inside the triangles. However, if it's a right triangle, okay, then from A, it would be this segment. Oops. From C, it would be this segment. And from B, it would be this segment. Okay, so notice for a right triangle, 2 are in on the triangle, and 1 is inside. Whereas in the acute, all were inside. Okay. Then we have the obtuse, and this is where the idea of a line that contains the opposite side. Because if we have an obtuse triangle, from A, the altitude would be right here. And that hits this line that contains the opposite side. Okay. From C, the altitude would be right here, and that hits the line that contains side AB. Okay? And the third one would be inside. So it would be from B to AC. So it would be right here. So for obtuse triangles, 2 of the altitudes are outside, and 1 is inside. And the one that's inside is the one that comes from the obtuse angle. Okay. Then we have the definition of perpendicular bisector. Okay. And it's defined, the perpendicular bisector of a segment is a line or ray or segment that is perpendicular to the segment at its midpoint. Okay. So if I have segment AB and I have segment JK, that is the perpendicular bisector, then I know this point of intersection O is a midpoint. That's the idea of bisector. So I know AO is congruent to BO. And I know that angle JOB is a right angle. That comes from the perpendicular, okay? So by the perpendicular bisector goes through the midpoint and is perpendicular to the line. All right, and that brings us to our theorems, okay? And it says, first one says, if a point, lies on the perpendicular bisector of a segment, then the point is equidistant from the endpoints of the segment. Okay, so here's what it means. Let's say I have segment AB, and XO is the perpendicular bisector of AB. Then the theorem says that segment AX is congruent to segment BX. In other words, these two distances are the same. So in other words, any point that is on the perpendicular bisector, if you connect that point to the endpoints of the segment, it forms an isosceles triangle, okay? So the key is that this segment is the same length as this segment. Okay, that's what the theorem says. So let's say that I had this point right here, point Y. It is on the perpendicular bisector. So therefore, according to the theorem, this distance has to be equal to that distance. So this equals this, okay? Point O is on the perpendicular bisector, and so AO has to be congruent to OB. Well, we already know that because by definition of perpendicular bisector, O is the midpoint of AB. So, and O is on the perpendicular bisector. So that means any point on this is the same distance from A as it is from B. Okay? The next theorem is the converse. And it says, if a point is equidistant from the endpoints of a segment, then the point lies on the perpendicular bisector of the segment. Okay, so these two theorems, this one and its converse, are very important. We use those a lot. Okay, so the converse says if you have a point X and you know AX is congruent to BX, then you know O is on the is on the perpendicular bisector. So therefore, this point O has to be a midpoint, and this has to be a right angle. Okay, so what this theorem gives you is it gives you this is a midpoint and that this segment is perpendicular. Okay, then the next theorem, two theorems, have to do with angles. So theorem, if a point lies on the bisector, of an angle, then the point is equidistant from the sides of the angle. Okay, so if you have angle A, B, C, and BX is a bisector, okay, in other words, angle ABX is congruent to angle XBC, then we know that the distance from X to this side of the angle and X to this side of the angle, that distance has to be the same distance. Okay, so we know that AX is equal to CX. Remember, this is C right here. Okay, and then we also have the converse. Okay, the converse says if a point is equidistant from the sides of an angle, then the point lies on the bisector of the angle. Okay, so again, it's just the converse. So if you know that AX is equal to CX, then ray BX is the bisector of angle ABC. All right. So let's look at a couple of examples. Okay, given this triangle, where this is SKT, and this is point R. Number one, if K is the midpoint of ST, then RK is called the what of triangle RST. Okay, well, RK is a segment that goes from the vertex, hits the opposite side at its midpoint. So therefore, by definition, it is a median. Okay. Number two, if segment RK is perpendicular to segment ST, then RK is called the what of triangle RST? Okay? Well, if it's perpendicular, okay, then it's a segment that goes from a vertex to the opposite side and hits it at a right angle, so that would be an altitude. Okay? Number 3. If K is the midpoint of segment ST and RK is perpendicular to ST, segment ST, then segment RK is called a what of segment ST? Okay, so if it hits the midpoint and it's perpendicular, then it's a perpendicular bisector. Okay. All right, next one. If I have triangle A, B, C, and I have segment BE, where I know that EC is congruent to AE, then what is the best name for segment BE? Okay, well, the best name for segment BE, it goes from a vertex, hits the opposite side at its midpoint, so the best name is the median. Okay. Then I have segment AD. AD goes from A, hits segments BC at a right angle. So the best name for segment AD would be an altitude. Okay? And if I have segment CF, and I know that CF gives me angle ACF is congruent to angle BCF, then the best name for CF would be ray CF, would be a bisector of angle ACB. Okay, and if I have this triangle, DFE, the segment FX, okay, and I have given that triangle DEF is isosceles with DF, or I'm sorry, length of DF equal to length of EF, and segment FX bisects angle DFE. E. Okay. Then we know that because it's isosceles, we know this is congruent to this. And we know that this is congruent to this. And we know this is congruent to itself. So we know that triangle DFX is congruent to triangle EFX. Okay? So would FX be a median of the triangle? Well, since we can prove them congruent by corresponding parts, we know this is congruent to this. Therefore, by definition, that is a median. So, yes, FX is a median of triangle DFE. Would the altitude drawn from F to DE be the same as FX? And yes, it would. Okay. All right.